Assalamu alaikum everyone. In today's video, we are going to learn about law of conservation of momentum. What is law of conservation of momentum? The total momentum of two or more than two interacting bodies in an isolated system always remains constant. That means, suppose if you have two bodies, first one with the mass m1 and the second one with the mass m2. m1 moving with the velocity u1, its initial velocity is u1 and the velocity of the second object is u2. Let's suppose the m1 is moving faster and it collides elastically with that body b. Then definitely there is a change in momentum. But if we calculate the total momentum of the system before interaction and after interaction, it will remain the same. That means the momentum may shift from one object to the other, from one body to the other body, but it will not change as a whole. The total momentum of the system always remains the same. That is what law of conservation of momentum talks about. And what is meant by an isolated system? A system in which no external forces act on a body. That means there is no frictional force, there is no gravitational force. Let's suppose we are ignoring these forces and talking about the system. But generally in practice we have these forces, but we are talking about a space. In a space we don't have these kind of forces over there. Therefore, if the bodies are colliding over there, then their momentum will remain the same. But some part of this law of conservation of momentum valid in real life. For example, in a game of snooker we saw that a cue ball is strike with any other of the balls, then the momentum shifted. So the momentum maybe decreases the total momentum, but it converted from one ball to the other ball. So that's what law of conservation of momentum talks about. To prove law of conservation of momentum, consider two bodies A and B of masses m1 and m2 moving with initial velocities of u1 and u2 before collision in the same line of action. We have two bodies A and B. They are moving in the same line. Definitely if they are moving the same line, they will collide if u1 is greater than u2. If u1 is not greater than u2, then they will not collide. So u1, let's suppose, is greater than u2. The body A is moving faster than body B and it collides elastically with the body B. After collision, what will happen? When the collision appears, after the collision, their velocities changes, not the masses. Masses of the sphere remains the same, but the velocities, let's suppose velocities, its final velocity, the velocity of first object A changes to v1 and the velocity of the second object m2 changes to v2. Now to prove law of conservation of momentum, we have two situations. When m1 strikes with m2, it changes the momentum of m2, and when m2 collides with m1, it changes or shifted the momentum of m1, which means the force exerted by A on B, this one is A and this one is B, the force exerted by A on B will change the momentum of body B, and the force exerted by B on A will change the momentum of body B. So how was the momentum changing? Let's see. The initial momentum of body A was m1 u1 and its final momentum is m1 v1. And if we are talking about change, then that's mean m1 v1 is the final momentum. We are gonna this with m1 u1, the initial momentum, then it will be the change in momentum of body A. For body A, it is the change in momentum. And similarly, we can find the change in momentum of body B. So we are going to substitute the values over here. For the body B, we are using m2 v2 minus m2 u2. This is the change in momentum of body B, and m1 v1 minus m1 u1, it is the change in momentum of body B with respect to time. If we are comparing this equation, what it says, For every action, there is equal and opposite reaction. Substituting the values of FA and FB, what we have find in this slide. So we are substituting the values M2V2 minus M2U1, cancelling out time with time over here. Now multiplying with this minus to this M1U1 and also with this one, so it will become positive and it will become negative. So minus M1U1 plus M1U1. As M1U1 is positive over here and M2U2 is negative over there, we are changing the position. We are shifting this M2U2 over there and M1V1 over there. In this scenario, we have M1V1 plus M2V2 equals to M1U1 plus M2U2. If we notice, this is the momentum of the first object before collision. It is the momentum of the second object before collision. And if we are going to add these, then this means it is the initial momentum of the system, because we have two objects in our system. And similarly, this is the final momentum. So what we have proved, that initial momentum of the system equals to the final momentum of the system. Momentum does not change. What the law of conservation of momentum says, the total momentum of two or more than two interacting bodies in an isolated system always remains the same or the constant. Thank you very much for watching the video. Inshallah, we will continue next video.